Hello everyone. Hope everyone is doing well. Everyone is taking care of themselves and their family members, and no one is going out of home except for getting essential things. So, welcome to the session, and I repeat the disclaimer of the last video. So, those who are able to watch this video, and if you know some of your friends staying in the remote area and they cannot you watch this video due to internet connectivity or issues in internet, please convey my message to them that it's completely fine if they miss this video or next couple of videos. It can be somehow managed later. They should stay home. They should not come out of home just to find a speedy network. Alright, so we'll begin with today's session. Then we'll have a quick recap of the last video, what we had spoken about. So what we had spoken about in the last video, we had spoken about classification and tabulation. So do you remember the three benefits of classification and tabulation we had discussed? Yes, the first one, unnecessary details gets eliminated. Yeah. Second one, the points where we have similar and dissimilar data are seen very clearly. And the third point is very important. The third point is it gives you the platform for comparison. And comparison is the base for any kind of analysis. To perform any kind of analysis on data, the common platform for comparison has to be there. So if you apply classification and tabulation, you go give a platform where statistical functions can be applied further to perform any kind of analysis. So those three were the benefits we had discussed, right? Then we discussed about how do you calculate the frequency of individual item and how do you calculate frequency for every class interval. Now these two are different approaches. Yes. So when you calculate frequency for each class, each individual item, then it gives you the idea which item is repeated most of the times, which item is found only once, which item is repeated hardly few times, or which items are missing from the entire range of the distribution. So this gives you the values which are repeated, not repeated in this approach, and the distinct values, the number of distinct values used. So this is one approach to understand the overall distribution. Then the second approach, where you have put the class intervals as per some convenient width, and then you have written the frequency for it. So that gives you the different approach. So this gives you the range in which you find most of the values in the distribution. This also gives you the range you find some of the values of the distribution. There can be some range in the entire distribution where you find no values. So this helps you to understand how values are dispersed over entire distribution. That is how the frequency distribution over class interval, that gives idea about this. So these were the things we had discussed in the last video. So today we will discuss about again frequency distribution table, but for two variables. This is also called as bivariate frequency distribution table. It is also called as two-way frequency table. So the two variables which are given, they are related with each other. So if you remember the previous example, what data we had for the previous example? Marks of students of in one particular subject, say statistics. Along with that, if marks of students in mathematics are given, then somehow there can be related. So while someone is good in maths may also be good in statistics. So for how many students it can be true? There can be one student who is really good in maths but not good in statistics. So that comparison you can find. So there you have the point of similar and dissimilar data points which are seen easily in the frequency distribution table. So this example will go for where we have data about two variables and we have to form a frequency distribution table for both of them. So here we go for the example. So this is the example. Roll numbers of students are given from 1 to 18, and for every student's marks in statistics and accountancy. This is the given data. Now if you see, if you look at the some entries here, now look at the roll number 9. Same marks in statistics, same in accountancy. No cheating. Then we have someone, roll number 1 with 15 in statistics and 13 in accountancy in the same group. Then we have someone with 8 and here with 5. Okay, so for individual it is a different case. Now we have to form a two-way frequency distribution table for this. So first we have to define the range or the class interval range for both of them. Now for both statistic and accountancy we have to define the class interval range. Now looking at it, the minimum value is 1 in both of them. Maximum value is in 18 somewhere here and here as well as 19. So we can conclude the marks ranges from 1 to 20. Then we have to define the class intervals. Now it is suggested that when you define class intervals, number of classes should be same for both of the variables. So now in this case, for statistics also I'll have same number of classes, and for accountancy as well I'll have same number of classes. So now in this case, so first I draw table this way. Okay, then I have to take column heads for one variable and row heads for another variable. Now this is going to be a typical table of rows and columns. So now let me take statistics for all these columns, column heads, and then accountancy for these row heads. So as we have spoken about the class range, so my minimum is 1, maximum is 20, so we'll get the class interval ranges of 5 each. So first is 1 to 5, then 5 10, then 10 15, and then 15 20. And here I will have a column called as total. Same here as well, 1 5, 5 10, 10 15, 15 20, and here I am going to have the column called as total. So now our table is ready. So now in each cell we have to write the frequency. Now remember one thing, for every pair we are going to mark only one tally. We are going to mark only one frequency. So we have total such 18. So 18, among these all we are going to mark only 18, but we are having values 36. So for every pair we will have only one mark. Now for the first one, statistics, it is marks are 15. So now 15 you will find in 2. For statistics it is column heads. So which column you have to select? So here two of them are having 15. Now here we are excluding the upper limit. So we have to consider 15 in this column. So this column is highlighted. So for 13 now you have to find the row in accountancy. So for 13 row is 10 to 15. So the intersection of 10, 15 and 15, 20 is here. So here my first tally mark goes for 15, 13. Then the second one is 1, 1. So 1, 1 is obviously is coming here. Then we have 1, 2, that also comes here. Second tally mark. Then we have 3, 7. So 3 comes in the first column, 7 comes in the second column, second row. So here we'll have 3, 7. Then 18, 12. 18 would come in the last and 12 here would come in the third one. So this is 18 for stat and 12 for accountancy. Then for 5, 9. So 5 you will find here. Here also there is 5, but we have to exclude the upper limit. So here I have to consider 5 here and 9 from this. So 5 here and 9 here. Both are coming in the same row, same. Then we have 4, 4 and 17. So someone is really bad in statistics and very good in accountancy. So 4 is coming in the first column and 17 is coming in the last one. Then 17, 16, 17 would come here, 16 would come here. Then 6, 6 would come here and 6 also would come here in this way. Then 19, 18. So it is last, 19 here, 18 comes here. Then we have 14 and 11. 14 would come in third column, 11 would come in also third column. So we'll have 1 here. Then 9 and 3. So 9 comes here and 3 comes here. So here we'll have. Then 8, 5. 8 again comes here. 5 would come in the next class. Alright, then 10, 10. So for 10, 10, we don't consider this as 10. We have to consider this 10 because here we are excluding the upper limit. So 10 here and 10 here. So here we'll have the second one. Then 11, 14. 11 would come here and 14 would also come here. So again in the same one. 11 and 14. Then we have 17, 18. 17, 18. Again the same this one. 17 would come here and 18 comes here. Then 9 and 15. 9 comes in the second column, 15 comes in the last column, last row. Then the last entry is 7, 3. For 7, 3, 7 comes in the second column, 3 comes in the first. So we are done with all the tally marks. Now let me count, write the count. So this is 2, this is also 2, this is 1, this is 3, this is 3, this is 2, this is 3, this is 1 and this is 1. Okay. So total frequency, total count should always give me 18. So now 2 plus 2, 4 plus 1, 5 plus 3, 8, 10, 13, 14, 15, 18. So it is giving me correct 18. So now here in this total I have to write the total of every column. So 2 plus 1 plus 1, this is 4. This is 2 plus 3 plus 1, which is 6. This is 3 and this is 5. Okay, and here I have to write the total of every row. So this is 2 plus 2, 4. This is again 4. This gives me 5 and this gives me 3. So 4 plus 4, 8. 8 plus 5, 13 plus 3, 16. Sorry, this is 5. 3 plus 1 plus 1. So 4 plus 4, 8. 8 plus 5, 13 plus 5, 18. This gives me 18 total, which has to tally this also. 4 plus 6, 10 plus 3, 13 plus 5, 18. So the grand total is 18, which should always match with the total frequency given. Now what do you understand from this table? So here, these 4 classes and these 3 classes, they have the similar data. They range in the same. So whereas these two have the dissimilar data. So now for this range, for statistics, most of them, that is 6 is the frequency where most of them have scored between 5 and 10. But for accountancy, it is almost same for all the classes. So distribution is this way. So now these ranges where you don't have any data. So this is how, by using band frequency table, you understand how the distribution has of the values is. So that's all for today. So today we have learned about bivariate frequency distribution table. Then wait for next concept. So till then, stay home, take care of yourself, don't go out of your home except for getting essential things, and we'll meet in the next video.